Can we find a missing side on a right angle triangle? This is a very, very useful skill. We're given this triangle, right? We're given an angle of 65 degrees. We're given a side length of 25, and we have to find this x. How can we find the x? Okay, well, we're actually going to start off very similar to how we started off those previous problems. We're going to label the sides. So if I'm labeling with respect to this angle down here, this is the angle that we're given. The hypotenuse, we're just going to call it h. I'll do it in blue. H is the hypotenuse across from the right angle triangle, or right angle. The adjacent side is the side beside the 65, so we'll call that the adjacent. And then the other side is the opposite side. So that's always the first step, is to label. The second step, actually let me write that down. The first step is to label. And we label O, H, and A. The second step is to figure out which one of those trig ratios is going to be useful in this question. So if you look, in the question, we're trying to find this x. Which side does that x correspond to? Well, it's the opposite side. So we're basically trying to find the opposite side. Which side are we given? We're given the hypotenuse, h. So the two useful sides to us in this question, I'm just going to highlight them, are the opposite and the hypotenuse. We don't really care much about the adjacent in this question, right? We're not given the length of it. We don't care about it. So the question we have to ask ourselves is which one of those three trig ratios has opposite and hypotenuse in it? So let's go back to those three trig ratios. Here they are. Remember, we want a trig ratio that has opposite and hypotenuse in it. Which one has that? Well, if you look, there's only one of them that has both opposite and hypotenuse in it, and that is the sine ratio. So that tells us that we need to use the sine ratio for this question. So going back down to this question, the next thing we can put down is the sine ratio. And we know sine of an angle is, if you use your SOHCAHTOA, SOHCAHTOH. This is useful just to write at the top of your page because you can tell right away what sine is. Remember, sine is just O over H, opposite over hypotenuse. So there we go. We now know we can use sine to help us with this question. So the second step here is identify the correct trig ratio. Okay? So that's the one. Sine is going to be useful here. For another question, it might be cos or tan, but here it's sine. Then we need to plug in the things we know into this equation. Basically, this you can look at it as a formula, right? We can plug some stuff in. So we know that the angle that we're dealing with is 65 degrees. So instead of the A, let's put 65 degrees. We also know the hypotenuse, the H, is just 25 meters. So instead of H, we're going to put 25. And also, O, we know that that's the X we're trying to find. So that's it, X. So what we have right now is an equation that we can just solve for X. X is that missing side, so once we've done that, we basically have our answer. So how do we do that? Well, remember, your calculator, if you look at a scientific calculator, it has buttons for sine, cos, and tan. If you plug in sine 65 on your calculator, it should tell you what the ratio is. So when I plug in sine 65, on my calculator, I press sine 65 equals, and it tells me this is 0.9063 equals x over 25. If you don't get that, it's possible that your calculator's in the wrong mode, or you have to input it differently. Some calculators, you have to put in the 65 and then press the sine button. So try that. If that still doesn't work and it's giving you a different answer, your calculator needs to be in degree mode. So let me just make a note of that. Calculator must be in degree mode. Usually it's called DEG mode. And there's probably a button or a set of buttons you have to press to change the mode. So some calculators have a button that literally says mode, and you press that and you go through some menus and you need to change it to DEG, D-E-G mode. Or sometimes it just looks like a D. The other modes that you'll get will be like a G or an R. You don't want those. You want the DEG mode. If you're not sure how to change your calculator into degree mode, Google it. Put in your calculator model. It usually says the model number on the calculator. Put that into Google and say, turn into degree mode. And it should give you instructions on how to do that. Okay, so anyways, back to this. We have now an equation with just an x in it that we can solve. So we want to get the x by itself to solve for x. How do we do that? Well, in this case, x is being divided by 25, so we can just look at this in equation. How do we get rid of a divided by 25? All we need to do is multiply both sides by 25, and that's going to cancel that out. So 25 times 0.9063 is just 22 point, I'll round to 2 decimal places here for our final answer, 66 equals x. So all that's telling us is that our x, our missing side, right here, is 22.66. And if you notice, the units we're given here in this part is meters. So the answer should actually be, therefore, x equals 22.66 meters. There we go. So, to finish off our steps here, step 1 was to label the opposite, hypotenuse, and adjacent. 2 was identify the trig ratio. And 3 is to solve the equation. The equation isn't very difficult usually. It's only like a 2 or 3 step equation depending on what's given. But you are going to need to do that to solve the answer. So, the next question, I know it's going to be a little bit tricky, but I still want you to try here. At least try to see how far you can go before getting stuck. So pause the video, try it yourself. When you're done, unpause, and I'm going to go through the whole solution. Okay, let's do this solution together. So our first step is to identify the opposite, hypotenuse, and adjacent. Well, if we look, the side that we're given, or the angle that we're given, I should say, is this 12.8 degrees. So the hypotenuse, we know that hypotenuse is going to be the long side right there. The x is going to be our adjacent, and the 1.7 is going to be our opposite. So hopefully we're good at labeling that. That's the first step. The second step is to identify the trig ratio that's going to be useful to us. So what do we care about and what do we not care about? Well, in this question, the sides we care about are going to be this adjacent side and this opposite side. We don't really care about the hypotenuse in this question. It's not what we're trying to find, and we're not given it. So let's look at our SOHCAHTOA up here. SOHCAHTOA tells us what each trig ratio is. We're looking for the one that has O and A in it. Which one has O and A in it? It's this one, right? TOA. That's our tan ratio, right? So it's telling us that tan is equal to opposite over adjacent. So I'm going to write that down. Tan of our angle is equal to opposite over adjacent, right? So there we go. We've identified the correct trig ratio to use. So the next step is to plug in everything we know. So tan, instead of A, it's 12.8 degrees equals opposite over adjacent. Opposite is the 1.7 feet. And the adjacent is just our x, we don't know. So this is a little bit of a different case because in the previous question, notice how the x was here, right? And we could just multiply by 25 to get rid of that. This one's a little bit trickier because the x is in the bottom. So there's a few little tricks. When the x is in the bottom, one thing you can do is flip the fractions. So what I like to do is pretend this is over 1, like this. And then what you can do is flip both sides. Flip this side and flip this side. This gets x to the top. So what it's going to look like is this. 1 over tan 12.8 equals x over 1.7. Do you see how I just flipped the fraction on both sides? Now the x is beautifully in the top for us, right? It's in the numerator, which is what we want. It's much easier to solve when x is in the numerator. And then we could do the same thing that we did before. We can multiply both sides by 1.7 to get rid of that 1.7, right? So if I multiply that side by 1.7, that's cool. I can also multiply this side by 1.7, and that's cool as well, right? So then we're just left with x. Notice also how I didn't simplify. I didn't plug tan 12.8 into my calculator yet. It's because if I do that at the end, I get a more accurate answer. I don't round anything until the very end. So what I'm going to type into my calculator to solve this side here is just 1.7 times 1 divided by tan 12.8. I should be able to do that in one step on my calculator. 1.7 times 1 divided by tan 12.8. If you can't do that in one step on your calculator, that's fine. Do it in multiple steps so you can plug in tan 12.8 to get that, and then do 1.7 divided by that. But it should come out to x equals 7.48. And if you look at the units come from the question, right? So the units in this case were feet. That's the distance we're given. So that's the answer, 7.48 feet. And that makes sense. If you look at the triangle, this side was 1.7 feet. The angle is very small, so it makes sense that the x is longer, right? So now we know that missing side from that triangle. There you go. So the only thing different about this question, first of all, we had to use tan instead of sine because we were given different things. But the other difference is that the x was on the bottom, so we just had to flip both sides. Okay? This is the thing that the kind of thing that you only get really good at by practicing it a lot. So keep on practicing. There are 3 questions on the next page. I want you to try those questions yourself. It's the same idea. You're going to follow the same procedure. Try them yourself. When you're done, when you think you have answers, you can unpause the video. Or if you get really stuck, you can unpause the video, and I'm going to reveal to you the 3 solutions to these problems. Okay? But before you do that, always remember the steps. Number 1, identify the opposite hypotenuse and adjacent. Number 2, identify the correct trig ratio, and then you can plug in the numbers. And part 3 is just solve the equation. Okay? So pause the video here. Try these 3 questions. When you're done, unpause it to see the solutions. And there are the 3 solutions. Notice how I wrote down SOHCAHTOA at the top of my page again, just to help me remember which one's which. For the first question, just to go over them all very quickly. For the first question, notice how it was the opposite and the hypotenuse I was concerned with. So that means I need to use sine, because that one has opposite and hypotenuse. So I used that, I plugged in the values, and then when I solved, I got 5.74 centimeters. For the second question, I noticed that it was opposite and adjacent that I was concerned with in this question. So that means I use tan, because tan, go back to our SOHCAHTOA, tan is the one that has opposite and adjacent. When I plug in my values, I notice that y is on the bottom. So I can flip both sides, both fractions, and then I needed to multiply by 6.2 to get rid of that 6.2 to get 4.34 meters. The last one, I noticed it was adjacent and hypotenuse. That means it's cosine that I needed to use, which was adjacent over hypotenuse. Again, if I plugged everything in, I noticed the z was in the bottom in the denominator, so I needed to flip both sides. And then in order to get the z by itself, I needed to multiply both sides by 145, which gave me an answer of z equals 235.52 inches. So there we go. That's how you find missing sides using trigonometry. Now notice how there's a last question down here. Check your understanding. Could I use the same process to find this missing x here? And the answer is no. And the reason why is because this is not a right angle triangle. If we find the missing angle, we do 180 minus 82 minus 42. We get this angle here is 56 degrees. So this is not a right angle triangle. We can only do this process when it's a right angle triangle. Okay? So you always need to see that little right angle in the corner, or always needs to say in the question that it's a right angle triangle. But that's how you do it.